So the last aspect of atomic structure I'm going to treat now is electronic configuration. So what is electronic configuration? This is the arrangement of an electron into the atomic orbitals of an element. So the orderly arrangement of an electron into the atomic orbitals of an element is called what? Electronic configuration. And the electronic configuration of an element can be governed by three rules. There are three basic rules that is explain or guide us how to write the electronic configuration of what? Of an element. What are the rules? The rules that govern the what? Electronic configuration. The first one we have Pauli exclusion principle. Number two, we have what we call Auerbach's rule. The third one we have what we call what? Horn's rule. So these are the three basic rules that govern the electronic configuration of an element in what? In periodic table. So let us take it one after the other. The first one is Pauli. So the Pauli exclusion principle states that no two electrons in the same orbit have the same four sets of quantum number. This man said that what? It can never possible for two electrons in the same orbit to have the same set of what? Of quantum number. That is what? Pauli. He said that what? It can never and never be possible for the same electron in the same orbit to have what? The same set of quantum what? Number. If you could still remember, our quantum number, they are four. Abi, which is what? N, azimuthal L, M, and what? And X. Principal, azimuthal, magnetic, and spin quantum number. And this manner said what? It can never possible for the same electron in the same orbit to have the same value for this what? Principal quantum what? Number. Take for example now, assume we have one what? One S2. Look at this one S2. The element here, the electron we have here, there are two. We have two electrons here. And the first electron is this, and this is the second what? The second electron. This is the first what? Electron. This is what? The second what? Electron. Both of them you can find out what? Inside the what? The s orbital. Or let me do it in this way. This one s orbital is it the same thing as what? As this? The first one spin up, the second one spin what? Spin down. So we have two electrons inside this what? One s orbitals. According to the what? To the Pauli exclusion, it said what? It can never possible for these two electrons to have the same value for four quantum number: principal, azimuthal, magnetic, and spin. Let us check it. Maybe the police is right. Police say that what? No two electrons in the same orbit have the same value for what? For four quantum number. Let's take it out. This first, this is what? Electron, Abi. This first electron is this. This is the second what? Electron. Or let me say, let me say we have S. No, let me do it this way. That this is the table. We have 11 what? Electrons. Or let's do it in this way. This electron, the first one spin up, the second one spin what? Down. Good. What are the value we are going to check? N for what? Principal. L for what? Azimuthal. M for magnetic. S for what? For spin. Now let us check their what? The value. The value for this what? The two what? Electron. According to the Pauli exclusion principle. So what? It can never possible for what? For these two electrons to have the same value for principal, azimuthal, magnetic, and spin. Let's check. Yeah. What is our what? Principal here? This one, energy level. For this first electron, principal is 1. For this second electron, principal is also what? 1. Abi? But for what? This azimuthal, our L, if you check the table I gave you that time, let me draw the table here because we use it here throughout. I said N orbital, Abi. I said we have L. Good. This N is 1 for S, 2 for P, 3 for D, 4 for what? For F. But this L is 0, 1, 2, 3. D is the value for what? For L. Abi? So what is the azimuthal quantum number for what? For X. For this X is what? Is 0. For this X, S orbital, our L for X is what? 0. For this same X is also what? 0. What is magnetic quantum number for what? For S orbital. We know that what? Magnetic quantum number for X. I've done it here. M is equal to the what? Plus or minus L. So it's equal to the what? 0. For this one, plus or minus 1. This one, plus or minus 2. This one, plus or minus what? 3. So the magnetic quantum number for S orbital is also what? 0. So 0, 0. So the spin for any electron that is what? Spin up. What is the value? Minus half. The one that spin down is what? Plus half. If you recall, I explained that one under this thing. Spin quantum number. I said two electrons. One will spin up, the other one will spin down. The one that spin up is what? Minus half. The one that spin down, we call it what? Plus half. So let us check it now. For these two electrons we have there, the one that go up and down, look at the what? Their value. The two electron, 1 and 2 electron, they have the same principal, which is 1, 1. They have the same magnetic quantum number, which is what? 0. Azimuthal quantum number, which is 0, 0. The two electrons have the same magnetic 0, 0. The two electrons, when they get to the what? To the spin, this one have minus, this one have what? Plus. You can see that what? It can never possible for two electrons in the same orbit to have the same value for what? Or for They have the same value for what? For four quantum what? Number. If these first three are the same, principal, azimuthal, magnetic, the spin must be what? Must be different. That's what we call what? You can ask that what? Which of the following quantum number explain the Pauli exclusion principle? Is what? Is spin. If the other two electrons are what? Are the same, note that what? The what is it? The s orbital will always what? Change. Let us solve this question under what? Pauli solution. We are given that what? If the 4D subshell is fully occupied, give the set of four quantum number of each electron. We know that what? This 4D be what? Orbitals. It is can accommodate maximum number of what? Of 10 electrons. The cell is fully what? Occupied. Abi? So it contains what? 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now what is what? If the 4D subshell is fully what? Occupied, that is what? The total number of electrons can be found in D is what? Is 10. So it's fully what? Occupied. Now what? Give the set for four quantum number of each electron. So to solve that, thing is very easy. That is what? It is D. Abi? From here, what is the what? The this is D. Azimuthal is what? Is 2. Magnetic is what? Plus or minus what? 2. Abi? But the energy level here is 3. Can I use this one? The energy level here is what? Is 4. Which is principal quantum number. So you can now say what? You draw your table in this form. So by drawing the table, the first thing we need to what? To show that what this is what? 11 what? Electron. After that, the next one we have is what? Is N. So the second one, after N, the next thing we need to throw is what? Is L. L is what? Magnetic what? Quantum number. And the next one is what? Is M. L is azimuthal. M is what? Magnetic quantum number. And the last one is what? Is X. What does X stand for? X is what? Is spin. So yeah, let us look at the what? Their value. So you can see how many electrons we have here? 10. This is the first electron. This is the what? Second electron. Third, fourth, fifth, sixth, seventh, eighth, ninth. This one will be what? 10. So we have 10 what? Electron. So good. What is the principal quantum number here? N. N is the number we have in front of what? Of orbital, which is 4. Here, what do you have in front of orbital here? Is 1. N is 1. So here, your N here is what? Is 4. So 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. All these electrons, they are in what? 4D orbital. What is azimuthal? So see, the azimuthal quantum number for D is constant, which is what? Is 2. For D is constant, it is what? 2. Don't subtract 4 minus 1 here. Oh. The azimuthal quaternion, which is L for what? For D is what? Is 2. It's constant. Where for what? For X is what? Is 0. That's why we use what? 0 throughout here. So here, our L for D orbital, L for D orbital here is what? Is 2. Abi, you now have what? 2, 2, 2, 2, 2, 2, 2, 2. Good. But in the case of what? Azimuthal or magnetic is plus or what? Plus or minus 2. This plus or minus 2, it starts from what? Minus 2, minus 1, 0, plus 1, plus 2. Abi, yeah, you now start it from here. We have 5, Abi. So this will tell you that what? This first cell here is minus 2, minus 1, 0, minus what? Plus 1, plus 2. Good. This first 2 electron can be why in what? Minus 2. I say what? Minus 2, minus 2. They are followed by what? Minus 1, minus 1. The next one is what? 0, 0. In this 0, you have 2 electrons. Next one is what? Plus 1, plus 1. Here we have what? Plus 2, plus what? Plus 2. So out of the spin, the one that spin up is minus half. That spin down, plus half, minus half, plus half, minus half, plus half, minus half, plus half, minus half, plus what? Plus half. So this is the what? This 4 set of quartile number of each electrons. If you check it out, the 2 electrons we have here, no 2 electrons in the same orbital have the same what? The same set of quantum number. Note, if principal magnetic and principal azimuthal magnetic are the same, the only spin with what? With difference. That is Pauli exclusion principle.